Assalamualaikum and hi, my name is Azleen Binti Zulkafplee. I would like to present the final year project 2 with title Prediction of Future Temperature by SDSM and PRECIS at Catchment Bukit Merah. As we know, Malaysia does have an equatorial climate, which implies that it is hot and humid throughout the year. The purpose of this study is to predict temperature variable at the Bukit Merah catchment in Perak. The Statistical Downscaling Model (SDSM) had been used to downscale temperature variable under two alternative representative concentration pathway scenarios (RCP4.5 and RCP8.5) to generate future climate data. The SDSM was performed by comparing daily temperature data from 2010 to 2020 as the input and baseline readings. The second generation Canadian Earth System Model predictors selected were used to simulate the temperature variable for future periods of 2030, 2040, and 2050. The maximum temperature data provided by SDSM under RCP 8.5 was indicated to be higher than RCP 4.5 according to the result. In comparison to the statistical model result, the integrated model from NAHRIM research using the regional climate model PRECIS revealed a lower value. Okay, for the introduction, temperature records in the Earth's atmosphere have convincingly demonstrated that the planet's climate is warming. As a result of global warming, climate change research has gained a lot of importance during the previous few decades. Global climate change is affecting water resources and other aspects of life in both developed and developing countries. According to some research, Peninsular Malaysia is predicted to see a consistent average temperature increase of between 0.5 degrees Celsius and 1.5 degrees Celsius. Temperature and rainfall in Malaysia's heavily irrigated area will increase by 0.2 degrees Celsius and 4% every 10 years between 2020 and 2099. The SDSM's downscaling method has been utilized in some of meteorological, hydrological, and environmental evaluations, as well as in a range of geographical contexts, including Europe, North America, and Southeast Asia. Besides, a few research findings use the Providing Regional Climates for Impact Studies PRECIS, a third-generation Hadley-centered RCM, to predict the possible future uncertainties of climate instability and climate change at a regional scale across various regions of the world with a cost resolution. There are two objectives of the study. First, to analyze the present and future temperature variable at Bukit Merah Reservoir by using the SDSM model, and the second one to evaluate the outcomes of the SDSM and PRECIS, which is based on NAHRIM models. Okay, the scope of the study is focused on operating the Statistical Downscaling Model (SDSM) for temperature variable at Bukit Merah Reservoir for a future period of 2021 to 2050 years. This study collects the historical temperature data from years 2010 until 2020 at the temperature station available in Ipoh to evaluate and process it using the SDSM model. Hence, the future temperature variable by SDSM will be compared to PRECIS model data from NAHRIM research. So, for the methodology, we start with the temperature variable data which were collected at Station Ipoh from years of 2010 to 2020. The SDSM model requires data such as local observation data, which is temperature data, known as predicting, and larger scale data diverse atmospheric variable, known as predictor. Future climate predictors were chosen from among the National for Environmental Prediction, which is NCEP, predictors that have a high correlation with the observed predictors. To this end, different correlation tests were carried out by screening the variable in SDSM software. To calibrate the SDSM, 70% of the data from the baseline period were chosen for model building and 30% for SDSM validation. After calibrating and evaluating SDSM performance in modeling the baseline era, the climate variables for the future periods were downscaled and projected on the SDSM model. Meanwhile, the Providing Regional Climate for Impact Studies PRECIS model was used to compare the result of future temperature data by SDSM. The National Hydraulic Research Institute of Malaysia, which is NAHRIM, has a team of highly experienced researchers that perform an investigation on future climate change projections. One of them was the forecasting of future temperature variables using historical temperature data at the Ipoh station from years 1971 until 1990 as a baseline. Okay, next we move to the result. In this study, there are two selected predictor variables for each minimum and maximum temperature. According to the findings, R2 values were greater than or equal to 0.3, which delivered excellent performance during both calibration and validation of temperature variables. The calibrated and validated data yield higher correlation, which is R value, that were closer to 1 for both minimum and maximum temperature simulations. Hence, it demonstrates that the value correspond well to historical data. Okay, so first we can see the SDSM result. The RCP4.5 scenario shows a rising trend in maximum temperature projection of 1.24 to 2.04 degrees Celsius, while under the RCP8.5 scenario was projected to rise from 1.28 until 2.22 degrees Celsius in the period of 2020 to 2050 by SDSM, following a similar pattern to the RCP4.5 scenario. The month of January has predicted an upsurge in maximum temperature under RCP4.5, while December under RCP8.5. The temperature result revealed that the minimum and maximum temperature values have risen in all three feature areas, and under both scenarios, all simulated differences exhibited gradual increases. The average temperature will continue to rise at a pace of 1.2 to 2.2 degrees Celsius every decade, according to the result. Higher temperature were predicted for January, April, August, and December, which might be impacted by the change of northeast monsoon to the southwest monsoon. While for the PRECIS result, in comparison to historical temperature, predictions show that the mean temperature will increase by approximately 0.97 degrees Celsius in the 2020, 1.96 degrees Celsius in the 2050, and 2.87 degrees Celsius in the 2080s. March had the highest temperature, which value of 27.44 degrees Celsius until 29.37 degrees Celsius, while the lowest temperature report occurred in October with 25.4 until 27.34 degrees Celsius in the three feature periods. PRECIS temperature projections show a similar pattern in all feature eras, with temperatures rising from the 2020s through the 2080s. The PRECIS simulation outcome was solid and consistent with the Malaysian Meteorological Department (MMD) forecast of a 1.1 to 3 degrees Celsius rise by the end of the 21st century, relying on a regional climate model PRECIS. Okay, for the comparison between SDSM and PRECIS model, since the maximum temperature data from SDSM under RCP 8.5 was shown to be greater than RCP 4.5, the integrated model utilizing the regional climate model PRECIS produced a lower value when compared to the result of the statistical model under RCP 8.5. The SDSM model results in a slightly higher value of future temperature in the 2050s compared to the PRECIS model data, which is 34.35 degrees Celsius for SDSM, while 28.72 degrees Celsius for PRECIS. The lowest temperature value forecasted was 32.21 degrees Celsius for SDSM and 26.29 degrees Celsius for PRECIS in the 2050s. The simulation result of the SDSM and PRECIS models indicate that the greatest temperature will be attained in December and March respectively. In conclusion, the Statistical Downscaling Model (SDSM) software can anticipate current and future temperature data. Annual future temperature predictions under the RCP 8.5 scenario reveal a 34.35 degrees Celsius increase, which is higher than the 34.12 degrees Celsius increase predicted by the RCP4.5 scenario. When compared to the statistical model result, the PRECIS regional climate model prediction of future temperature generated a smaller value. The PRECIS projected the greatest temperature to be 28.72 degrees Celsius, which is lower than the SDSM prediction of 34.35 degrees Celsius and the RCP8.5 for the 2050s. Both models show high performance in forecasting future temperature utilizing historical data as the baseline. Thank you.